In this problem, we're told an astronaut stands by the rim of a crater on the moon, where acceleration of gravity is 1.62 meters per second squared. To determine the depth of the crater, she drops a rock and measures the time it takes for it to hit the bottom. If the time is 6.3 seconds, what is the depth of the crater? So the first thing you want to do is draw what's going on here. So we have this astronaut, and she's going to drop this rock, right? So it's going to fall all the way down on the bottom, and this takes 6.3 seconds. And what we're trying to do is find the height, or basically the depth of this crater, right? So how do we want to do this? So the first thing you always do for solving kinematic equations or kinematic problems with this is you always want to write down the variables you're given. So we're given the time, right? So you want to write down the kinematic variables for this interval. So we know the time is 6.3 seconds. So how long it's going to take. We're also told the acceleration. So just as on a free fall problem, right, on Earth, acceleration is minus 9.8 meters per second squared, right? In this case, it's going to be 1.62. Right, so it's going to be 1.62 because that's what it is on the moon, right? It's much less because it's much smaller than the Earth, right? So minus 1.62 meters per second squared. That's going to be the rate at which, right, the rate of increase at which it falls. So that's the acceleration. And then also, we're also given the initial velocity, right? So it's not told, but they want us to assume when you drop something, you're not putting any initial velocity on it. It just falls. So the initial velocity is 0 meters per second. So now we've got all these three variables, and what we're trying to do is find h, but we can find that by finding the change in y. So when we use kinematics, you find the change in y, right? So we want delta y, and we have three variables, and all we have to do is plug it in to solve. So if you look at our equations, the one we're gonna use is this one right here, right? So q minus has delta x, but delta x and delta y are replaceable. So what we're gonna do is just use this equation. So delta y equals v sub 0 times t plus 1/2 at squared, right? Because all we have to do is plug in v sub 0, we can plug in a, and we can plug in t, and we can solve for the delta y, right? Because if we know the change in y, it's going to give us the height, basically. So delta y equals v sub 0, which is 0, 0 times t, which is 6.3. 0 times 0 is still 0, so we can ignore that. 1/2 times acceleration, which is minus 1.62, multiplied by t squared. So t is 6.3 squared. So plug this in your calc, right? So it's going to be 1/2, which is just 0.5 times minus 1.62 times 6.3 squared. And when you do this, you're going to get delta y equals minus 32.1489. So notice it's negative, and why is that? So this is the change in the y position. So if it starts here, which we determine is 0, and falls here, the change in the y is going to be, we're going down 32 meters. Right, so if we go down 32 meters, what does that mean? It means the height of the crater just has to be the positive value, right? Because we're dropping 32, that means this thing is 32 tall. So basically it's about 32 meters, I'm just rounding. But yeah, 32 meters is going to be the height of the crater. And if we look at our answers, you can see that A is 32 meters. But yeah, so the height of the crater, or the depth of the crater, is 32 meters. But yeah, so this is your answer, and hopefully you found this useful.